If you haven't watched the movie Interstellar yet, I would urge you to watch it. Now, I'm not going to give you a review of it here. Instead, I intend to go inside it and tell what was actually going on. Many of the things shown virtually in it are hypothetical, but like Isaac Asimov, an American writer and a professor of biochemistry at Boston University, once quoted, "Today's science fiction is tomorrow's science fact." Now, I would like to believe in most of those unfathomable things described in it. In the movie, Cooper and his team with their spaceship Endurance set out to go through a wormhole near Saturn, opening a path to a fictional supermassive black hole called Gargantua, which is located in a distant galaxy. Now, the black hole is an object which is so dense that not even light can escape its surface, and there are mainly two parts to a black hole. This is the boundary that marks where the escape velocity from the mass is the speed of light, that is the point of no return. This is where once the matter is inside it, that matter will fall to the center called Singularity, where the mass resides. Due to the strong gravity, the matter becomes almost massless and has an infinite density at the Singularity. Wormholes are formed by merging of two far located singularities of black holes. Now, even in the wormhole depicted in this video, you can see that the wormhole mouth is actually shown as a circle. However, when seen personally, it is a sphere, and Romilly explains it beautifully to Cooper in the movie. A gravitational distorted view of space on the other side can be seen on the sphere's surface. The reality is more intricate. The two key complications are size and stability. The primitive wormholes are prophesized to exist on the microscopic level. It is possible to be stretched to a larger size as the universe expands. Stability plays another role as it collapses quickly. It is found that addition of exotic matter containing negative energy density and large negative pressure, it is still theoretically possible to send information or travel across a wormhole. If our present technology is boosted to a super advanced technology, we can not only travel between two separate regions within the universe, but traveling across two universes might also be possible through the wormhole. And that's not it. If one mouth of a wormhole is moved in a specific manner, it could allow for time travel. Still, it would be a Herculean task to turn a wormhole to a time machine. In the movie, after reaching the other galaxy, they plan to investigate one among the 12 potentially habitable worlds located near the supermassive black hole called Gargantua. The interesting part is that two of those planets orbit around Gargantua. Now, in reality, currently many studies are going on to find out whether a habitable planet can actually orbit a black hole or not. It is found that supermassive black holes have the potential for consuming everything in their path, from gas clouds to entire solar systems. According to thermodynamics, it's the difference between the source of usable energy and the sink for unusable waste heat that drives the processes that create life. The black hole itself is a sink and cosmic microwave background which appears as a bright star just on the edge of the black hole shadow, which would serve as the source. To receive strong CMB radiations, a planet should be present at the event horizon, which we know is the point of no return, and eventually the planet will be sucked in. Every hour we spend on that planet will be 7 years back on Earth. Well, that's relativity, folks. This is a dialogue from the movie about Miller's Planet by Romilly, which talks about an ocean world which orbits around Gargantua at its horizon. And a black hole that big has a huge gravitational pull. The reason behind variation in time is time dilation, that is, a moving clock runs slower than a stationary clock, or the faster you move through space, the slower you move through time. In this case, gravitational time dilation is the cause. It is a type of time dilation which is influenced by gravity. Higher the gravity, slower the clock runs. We know that the force of gravity is stronger towards the surface of the Earth than at a higher altitude. Miller's planet has a huge gravity when compared to Earth, and hence gravity on that planet will drastically slow down the clock with the crew, and thus Cooper could age slower than his daughter Murph, who lives on Earth. This phenomenon is described as twin paradox, which means that two twins born on the same date could have different ages if one were to travel near the speed of light while the other stayed on Earth. In the movie, skidding through the event horizon of Gargantua, Cooper and Tars eject from their corresponding craft and find themselves inside a gigantic Tesseract created by future humans, a civilization that has evolved past the 4 dimensions, the mysterious bulk beings, or they in the movie. The black hole's gravitational singularity is manifested here as the Tesseract, where one can navigate both time and space dimensions. This is due to the strong gravitational field warping space-time onto itself, which results in gravitational anomalies. For example, the dust particles which align themselves in some sort of compression and rarefaction in Murph's room, the future Cooper uses gravity to manipulate the dust particles, thus giving the coordinates of NASA's station to present-day Murph and Cooper. So is harnessing the anomalies to lift colonies of Earth, which was possible because Murph could solve the equation with the help of laws of quantum gravity that Cooper transmits to Murph's watch in Morse code by manipulating the second hand using gravity. So harnessing the anomalies to lift colonies off the Earth was possible only because Murph was able to solve the equation with the help of the laws of quantum gravity that Cooper transmits into Murph's watch in Morse code by manipulating the second hand using gravity. Quantum gravity is the study of gravity according to the principles of quantum mechanics, and where quantum effects cannot be ignored, such as in the vicinity of black holes where the effects of gravity are strong. In quantum gravity, our universe is considered as a membrane called brane residing in a higher dimensional hyperspace called bulk. When we apply Einstein's relativistic laws into this bulk, the possibilities of gravitational anomalies is found. These are anomalies triggered by the physical fields present inside the bulk. But in reality, the Tesseract, even if such a place existed inside a black hole, any living thing would be ripped off before even getting to the singularity, or even if they do get in there by any chance, they won't be able to escape from it and also won't be able to report what they see. I thank you all for watching this video. If you aren't subscribed to the channel, make sure you do click on that subscribe button in the bottom right hand corner, and I will see you in our next video. Take care.